Hello, everyone. Welcome to this first online session of our class on mathematics. We are trying this kind of an online class for the first time from our end in California and also from your end at Purnapramati in Bangalore. So you can expect that it will take us a few weeks to experiment to find out what's the best way to conduct these online sessions. Let me take a few minutes to introduce myself. My name is Omkar Deshpande. If you go by my formal degrees, I'm a computer scientist by training. I did my BTech in computer science from IIT Delhi, and then I did my master's and PhD also in computer science from Stanford University. I've been working in the software industry in Silicon Valley for the last 6 years. The first 3 years at a startup called Cosmix, which then got acquired by Walmart. And so I've been an engineer at Walmart Labs for the last 3 years, where I've been working on various projects in the e-commerce space. But recently, I decided that I would like to move away from a career in corporate life and devote my time to education, something that is very dear to my heart. Here in Mountain View, we have seen some well known online education companies being founded in recent years. Khan Academy and Coursera are perhaps the two most well known initiatives. There's a culture here that if you feel passionate about something, you just try out something on your own. And even if you don't do well, at least you would have spent some time doing work that was hopefully meaningful to you. And so I decided to start a private classroom based education program here in the Bay Area for middle school students, that is, students in grades 6 to 8. This program is called the Young Socratics. We just launched our website, theyoungsocratics.com, on which we will be posting a lot of videos, including the videos that you will be seeing in this class. I'll be teaching an intensive 8-week long summer class for 3 hours every day to middle school students here in the Bay Area. That's how we are formally launching the Young Socratics. Now, the reason why I decided to volunteer to have these online sessions at Purnapramati is that the kind of education I'm interested in contributing to is different from the regular education that schools provide, both in India as well as here in California for that matter. Purnapramati's vision for a holistic education is something that appeals to me too, even though our program here is limited to mathematics and science. But the way we want to cover mathematics and science is significantly different from the regular way. And let me explain a little bit as to how that's the case. One of the main areas of emphasis for us in the teaching of mathematics and science is the history of mathematics and the history of science. We want to understand how the great ideas in mathematics and science were originally developed. We want to meet the real people who developed those ideas. We want to examine their lives. We want to understand what motivated them, how they were influenced by the existing worldviews in their time, and what those existing worldviews were. Very often, we tend to think of past mathematicians and scientists as people who had very narrow interests, much like the specialized professional scientists and mathematicians of today. But in fact, as we go back further and further into the past, we find that the boundaries between the different subjects that we take for granted today did not exist. Newton, for example, did not see himself as a physicist. The profession of a physicist did not exist back then. Newton saw himself as a philosopher, as a natural philosopher, or as a philosopher who studies nature to understand the laws of nature created by God. What we call as science today was known as natural philosophy in Newton's time. His famous work, in which he introduces the laws of motion and gravitation, is called Mathematical Principles of Natural Philosophy. In that work, originally published in, I think, the year 1686 in Latin, Newton freely discusses in this work the attributes of God as he understood them. So the boundary between science and philosophy, or science and religion, did not exist in the time of Newton. So when we study the history of mathematics or the history of science, we are inevitably drawn into the domain of philosophy. And rather than avoid philosophy, or rather than avoiding history, I think science and mathematics should be taught in a way that is deeply blended with history and philosophy. On our website's blog, we have recently uploaded 4 videos on why one should study science in a historical way. I would encourage you to view these videos. The videos talk about why one should study the history of science, but almost everything mentioned in the videos applies equally to the history of mathematics. So, our education program differs from the conventional school instruction in the amount of importance we give to history and philosophy when studying mathematics and science. Apart from this, we also believe that, at least for young kids, games and puzzles are a very useful and fun way to develop an interest in mathematics, because many games have a mathematical structure to them, and if you uncover that mathematical structure, you can become better at playing those games. Since everyone enjoys playing games, that enjoyment would hopefully translate into an interest in mathematics. During these online sessions too, we'll spend some sessions playing mathematical games. You'll play those games with each other. We just have to find an effective way to do it online, since I'm not physically present there to guide you through those games. A third way in which we differ from the conventional school instruction is the degree of emphasis that we give to problem solving. Solving problems is different from solving exercises. What is the difference between a problem and an exercise?